Hello, my name is Caluã de Lacerda Pataca, and I'm a PhD student at the Rochester Institute of Technology, or RIT, where I am advised by Huenerfauth and Roshan Peiris, who are co-authors on the paper I will present today, along with Saad Hassan from Tulane University and Nathan Tinker, also from RIT. Our paper is called Caption Royale, exploring the design space of effective captions from the perspective of deaf and hard of hearing individuals. It reports on 3 studies where we explored and evaluated different design approaches for effective captions. Effective captions are captions that convey different emotional aspects of speech, for example, through visual changes to typography. Like regular captions, they will include everything that has been said, but it will also show whether a speaker had a positive, neutral, or negative tone, and how much excitement their voice carried. The goal with these interventions is to try to close the gap between text and speech. The way we speak can have very rich expressive qualities, most of which are lost when we transcribe words into text. In the context of accessibility of speech, this lack of expression has been found to be detrimental to communication between deaf or hard of hearing individuals and hearing conversational partners. Captioned speech is ambiguous, it is dull, and relying on it is a tiring task. So much so, in fact, that to try to close this gap between voice and captions, some researchers have explored ways of visualizing these speech cues through visuals in the text itself. The problem, however, is that while research has shown that captions that convey a speaker's emotions are generally more useful than captions that show acoustic features such as loudness and pitch, there has been little work on how to best design such captions to convey emotion. Figuring this out is the goal of our work. To do so, we explore the design space of effective captions to find typographic parameters that are able to represent, on one hand, whether words are negative, neutral, or positive, and on the other, how excited or calm the speaker was when they said them. To give a quick illustration of what we mean by having typography representing elements from speech, here's an example. Let's imagine someone saying the following phrase: a 40-year-old piece of electrical equipment without a scratch on it, how dare you, Ryan. Their tone of voice is tense and getting tenser. Using a state-of-the-art machine learning model fine-tuned to do speech emotion recognition, we can extract valence and arousal values for each word. Let's imagine then that we start this utterance at neutral valence and as we progress, get closer and closer to the lowest possible value. With arousal, let's imagine a calm start that gets more and more excited. Now, imagine that we map these valence values to different hues of a red tone, so that as words get more negative, we write them in a deeper and deeper hue. For arousal, we can start using a regular font weight, but as excitement increases, so does the thickness of each letter. These 2 visual parameters, font color and font weight, are independent, but we can combine them so that each word carries visual cues for both valence and arousal. This method of mapping changes in a speech feature to changes in typography has been around for a while, but as I was saying, the focus of previous research has been on showing acoustic features, with little exploration of emotional dimensions. Our first step in our work then was looking at this literature and cataloging viable visual parameters which we could repurpose for effective captions. We found 9 viable styles which I'll now show. 3 of them involved using color. The idea here is to apply changes in hue to either the letters, their background, or as a glow behind them, echoing different levels of emotion. A negative emotion, as we saw, can be represented by a deep red, while a positive one can be shown using blue-green colors. Other styles draw inspiration from prosody. Font weight and size, for instance, have been used to represent loudness, baseline shift, pitch, and letter spacing, rhythm. We also included a style where the opacity of words changed so that low values were almost transparent. Lastly, we included a special font where the actual letter forms would change from a very jagged letter shape to a softer one. Our paper describes several studies, which could be thought of as a tournament that slowly arrives at a top design over several rounds. In our first study, we employed these 9 styles to independently represent either valence or arousal. The reason for slicing things up at first, even though we are interested in having both dimensions at the same time, was that having all possible combinations at once would lead to a combinatorial explosion that would then make the study impractical. By focusing on each emotional dimension independently, we were able to eliminate some less likely choices for further analysis. The experiment itself employed a best-worst scaling method. Participants would watch short video clips with strong emotional overtones, and given a set of different caption choices, tell us which one was best for a given emotional dimension and which one was worst. This was a simple procedure, so we were able to have participants test out the caption styles many times, applied to videos with different stories, speakers, and general emotional charge. What we found is that there was a clear preference towards 2 color-based styles for valence, which outperformed the other 7 styles. For arousal, the picture was a bit less clear, with the tie between 4 top-performing styles. For the second study, we combined the choices from the first study into 6 novel caption styles that had both valence and arousal at the same time. Again, we employed a best-worst scaling method, where participants would at each round pick their best and worst option. With this, we were able to eliminate 2 further styles, ending up with 4 candidates which had high preference among participants. For the third and final study, we actually evaluated how effective each of these styles were at conveying valence and arousal. We did this by selecting short sentences taken from a set of videos participants watched and asked them to select the average valence and arousal values. That way, we could measure the distance between what they were perceiving with the captions and what we were actually representing as per the machine learning model's outputs. To make this comparison meaningful, we also included conventional captions, which didn't include any effective information. Presumably, the novel styles should be able to beat this baseline. Interestingly, we found that only 2 styles effectively did so. Not only that, we found that the performance for these 2 styles increased between the first and second time participants were exposed to them, an effect we did not find with neither the baseline nor the other 2 styles. This tells us that, even within the very time-restricted setting of our study, there was a meaningful learning effect, which, if these styles were to be employed and used for longer periods of time, we could expect to increase. We offered these 2 styles as design recommendations for developers of captioning systems. We discussed this in detail in the paper, but in summary, there was a clear consensus towards using font color to represent valence. For arousal, designers can either choose the font size or font weight. Comments from participants revealed that font size seems to have more detrimental effects to legibility, but its changes are clearer, while font weight is a bit more subtle but also easier to read.